Hey folks, Quilly18 here, and welcome to a brand new Unity tutorial. Today we're going to be doing a 2D physics game. These are games that are pretty popular both on desktop computers, but also on mobile devices. And the game we're going to make is going to be one that is perfectly suited basically to both and could be ported over one way or another. So we're going to talk about a little bit more graphic stuff and some physics stuff, and also how to sort of pull and drag things with the mouse, and also do some neat line effects. So we're going to do that right away. I'm going to go ahead and start a brand new project over here. I'm going to stick it here. We're going to call it 2D physics game or something. You might want to come up with a better name. Tell you what, I'm going to call this 2D box stacker. That's going to be the name of this game here. We're going to set the defaults for 2D just to make life a little bit simpler for us. We're not going to import any of the projects. Note that I'm running on Unity 4.5.5 F1. If at any point you have any problem with your project, make sure that you're running on the same version or newer. I am going to be running in the Pro version of Unity. However, nothing that we're going to do is going to require the Pro version. You can use the free version and it's going to work perfectly fine. This is my layout over here. In my last 2D tutorial, I showed you how you can sort of rearrange things if you want to copy my layout exactly, but it doesn't really matter what you've got going on. So we are going to make a game that involves taking sort of 2D boxes and stacking them up on top of one another. So we're going to talk about collisions, we're going to talk about gravity, physics, various events, and also the ability to click and drag objects and move them around in space. Some of the stuff we're going to do here is actually going to be applicable to a 3D kind of setting as well. I'm going to try to mention the differences where they are. It's actually going to be pretty damn similar from one to the other. So what I'm imagining is a game where we've got a sort of one base platform, and then boxes that, I don't know, fly in from the side of the screen or get shot up by a cannon from side to side, and you can catch them and sort of put them on the platform, and you're just trying to stack things up as high as possible before the whole thing kind of topples over and collapses. So let's go ahead and start off with importing a few graphic assets. Once again, I've gone to the Open Game Art website, which features a lot of CC0 Creative Commons license things, which are free to use in every way. I'm going to have a link down below to this particular set of graphics. It's a 2D physics graphic pack, which is pretty handy. So what I'm going to do is I'm going to start off by pulling in, I've got a graphic here, Element Metal 013. It's sort of a, I'll drag it into the view so you can see it. It's sort of a rectangular platformy kind of thing over here. So I'm going to start with this as the base graphic. Now, let me clear that out. This image here, this is a graphic file. It's simply a PNG file. And because we have our default set to 2D, by default, Unity is pulling this in as a sprite. If you forgot to do the 2D setup, it'll pull it in as a texture. Just make sure it's set to a sprite, and that's going to be totally fine. Now, by default, it pulls it in as a single sprite mode. In the last 2D tutorial, we used one big sprite sheet with multiple graphics, but now I'm using a single sprite in a single image file, so single mode is fine. Note, we can still load up the sprite editor if we want. If for any reason there's any sort of empty space or padding around this graphic, we could go and just kind of crop it, but here it's totally tight. Our graphic goes right up to the edge of our actual image file, so that is perfectly fine. So there we have it. We can still expand this and see that it's got one element inside. Because it's a single sprite, it doesn't matter if we drag this or this in. They're both going to be identical. Doesn't matter what we start by dragging. So, all right, we've got our first image in here. So actually, I suppose we will go ahead and add it to our scene. So we can do that by just dragging it into the scene. I'm going to center everything. I'm going to take its position. I'm going to set its X to 0 and its Y. Well, let's set it to 0 for now, but let's talk about where we want our things to be positioned. We've got our camera over here on the left-hand side of the screen. And this is our actual game view over here. So now, because our element is at 0, 0, it is currently centered. Is that what we want? I think what we're going to want is this platform to be at the bottom of the screen. What about the size of our graphics? Do we want this to be a little bit bigger, a little bit smaller? I feel like it should probably be a little bit bigger. Now, part of it, of course, will depend on kind of sort of what aspect ratio the game is meant to be played in. So imagine you're imagining a game that's meant to be playing on a phone in this sort of vertical layout. That might lead you to make different design choices than if you were imagining the game to be played on a phone in a widescreen layout, for example. Slightly different implications in terms of what the gameplay will be, what the controls will be, all that sort of thing. I'll go ahead and imagine that we're playing maybe a little bit more in this sort of vertical orientation. I think that'll be a little bit more satisfying as we build our tower up. So right now, I think our graphic is still a little bit small for what I'm planning personally. So there's a couple of different ways we can do it. We could go ahead and just scale this image up. I'm going to suggest that this is not the way we want to approach this to start off with. I would rather have it set up in such a way that everything works the way we kind of imagine it, with the scale set to 1 everywhere. So there's two things we can do. One, we can go to the main camera, which is set to orthographic projection by default if we're in 2D mode. If you're not in 2D mode, it will be set to perspective, which is a normal sort of more 3D-ish kind of view, but that's not what we want. So make sure we're in orthographic mode. And then we've got the size thing. If we shrink the size of the projection, what we end up with are effectively larger graphics, because basically the size of your screen or the size of your camera is being shrunk down, so everything that you see in it effectively takes up a lot more space. So we could tune our graphics by changing our orthographic projection. The other thing we can do, rather than scale the actual game object in game, which does work, right? We can stretch it in different ways, and that's fine. The other thing we can do, if we go back into our project and check our import settings, there's this one value right over here, pixels to units. This tells Unity for every how many pixels in our image, because our image has a certain number of pixels in it, how many pixels in this image works out to 1 world unit. The world units, you can see, are the grid in the background over here, right? Each one of these squares is 1 unit in Unity. So if I take, for example, if I take my element over here and I give it a y of 1, it'll move up 1 world unit in space over here. So you can tune the size of your elements by tweaking this pixels to unit kind of thing. And really, I think those are probably going to be two things, where you set your main camera in such a way that you're comfortable at first, and then you tweak your other graphics appropriately. What I'm going to do, before I go and tweak any of those things, I'm going to go ahead and bring my box into my project. This is my graphic for my box, and I want to see how big this box graphic looks in-game, and then make a decision on there. Okay, I think these boxes are pretty good. I might want them a little bit bigger to make them easier to click and sort of drag. So since both graphics feel a little bit small to me, I'm going to start off by shrinking the orthographic projection. Maybe we'll go to a 3. All right, that's not bad. I still think the platform could be a little bit bigger. So what I'm going to do at this point is I'm going to take my platform, which I will rename here to platform. I will either scale it up, or I'll go into its import settings and change its pixels to units. I'll say it only needs 75 pixels to equal 1 world unit. And you know what? I think that's a pretty good size. So now the advantage of it, I just like the fact that our graphic is not scaled here. I like having everything to be at 111 because it just makes everything a little bit more predictable. All right, I like that size. Now, I don't like its positioning. I want it to be at the bottom of the screen. So what is the correct positioning for it to be right at the bottom of the screen? Well, all right, we've got a bit of an issue here, because is it always going to be the same place? If I stick this at, say, minus 2 point, let's call it 2.5 even, is that always going to be the bottom of my screen? I mean, we know if we drag this way, things get moved. What if we drag up and down? It doesn't change. It stays at the bottom of the screen. And why is that? Well, that's because in orthographic mode, the size here, this is the distance in world units from the middle point of the screen to the bottom of the screen, or the middle to the top. It's the same thing. This will always be 3 world units. The actual size on screen might change, for example, and therefore take up more pixels or something like that. But everything gets scaled in such a way that no matter what, from the middle of the screen to the bottom, or the middle of the screen to the top, it will always be 3 world units. You can't make the same sort of determination from left to right, though, because that scales in a different kind of fashion. Or rather, it doesn't scale. You just get more real estate to play with. So with this positioning, we're okay. I think what I'm going to do, though, rather than have it sit around here, I'm going to take this platform and move it down by just dragging on the Y over here, and sort of put it into the ground like that. Okay, that's the sort of effect that I want. I want it to sort of be there, and this is where we're going to be building on top of. So let's go to our element wood 010, which is the name of the graphic, and we're going to go ahead and rename this to something like box. I'm going to organize my project right away. I'm going to create a folder for images, and I'm just going to move these images in there. Yeah, apply. What? Okay. That was weird. What was getting applied? Oh, I didn't want to change that on the wood. There we go. I must have had multiple things selected when I was changing the pixels to unit. My bad. Because I want the pixels to unit on the wood to stay at 100. Okay. So we've got our box over here. So we have our images, and note that that is different from our game elements. I'm going to go ahead and make these into prefabs to make it a little bit more explicit. So we'll make another folder for prefabs. and we're going to go ahead and drag the platform in there and the box in there as well. So I don't think we actually truly need platform to be a prefab because it's unlikely that we'll ever have more than one. But we are going to get to a point where we're going to have multiple boxes, and we want to be able to have them all be identical, which means pulling in more instances of the prefab. So that's not bad. I think the game might look a little bit better with a background as well. Luckily, I have a graphic set up for that as well. I've got this blue land. This is all from the same texture pack. I'm going to go ahead and drag that into the world, and I'm going to go and center it at that point. So we run into our first problem at this point, which is we can't see anything anymore. Why is that? Well, if we, in our scene editor, we can flip between the two modes. And, well, we can see that everything is literally on the exact same plane of existence. And so which one you actually see is semi-random. We can influence things because the camera is over here at the left. If I take my background and move it to the right, now all of a sudden we can see everything, right? So you can tell that everything in a 2D project by default is aligned in such a way that it's 0 on the Z-axis. So, and the camera's at -10 over here. So if you give something a positive Z-axis, it moves behind everything else. The other thing you can do is you can use these sorting layers and the order in the layer to determine how things get placed. I'm going to go ahead and just set my background to a Z position of 1. That is going to be perfectly fine, and then we don't have to worry about these sorting layers and orders and layers. But if you've got a bit more of a complicated 2D project, you're probably going to want to go ahead and be in a position where you can manipulate these two a little bit. So, now that we've got that, and we've got a pretty background, are we happy with the size of the background? Maybe we'll want to shrink it down a little bit. I don't know. I actually don't know what I want to do with this background. It's got some nice puffy clouds. Let's go ahead in the blue land here. Let's go and shrink, or set the pixels to unit. We're going to say it needs 200 pixels to be 1 unit of world space. Nope, that's definitely too small. So let's say something like 125. There we go. So that's pretty good. But is it possible that we're ever going to get to a situation where the camera is no longer showing the background? It'll be too far over to the side or too far to the top. Well, it depends on what kind of project you're running. In this project, what I'm envisioning is as you grow your tower, we're going to keep moving the camera up and up and up and up and up and up. So what are we going to do when we run out of background there? Lots of different things you can do. In this situation, what I think I'm going to do is I'm going to take the lazy way out. I'm going to set the background for this camera. I'm going to use the eyedropper tool and just click right over here so the background of the camera matches the color of the sky over here. And then what we might do is throw in some more fluffy clouds or something as we go up and up and up. But I think it'll be enough to give it a sort of a sense of movement over here, that as the game progresses, it'll just move up this way, and then you just more and more into open sky. Maybe you're going to want to introduce some space graphics or something if you get high enough. Depends entirely on the kind of game you're making. All right, so we've got our first box. We've got our first background. Well, what if we go and save our scene, which I like to do. I'll just call it, I don't know, just scene. That way I can keep hitting Control S and saving my changes. There we go. So we've got our images, our prefabs, and our default scene. We haven't added any scripts yet, and that's okay. Let's go ahead and try to add some physics to this game. So the first thing we're going to do is we're going to take a look at our box over here, and we're going to make it a physics-enabled object. That requires two things. One, it requires that we give this object a collider. A collider will define this object in space and basically tell the physics system how big this is. So if we go ahead and type in here and type in collider, you can see that there's a lot of different colliders available in the game now, or in Unity. Because we're doing things in 2D, we're going to want to use the 2D colliders. What the big difference between the 3D and 2D colliders is that you can sort of imagine in a 2D collider that they are infinitely big along the Z-axis. So it doesn't matter how far ahead or behind any particular images, it'll always collide in things in these two ways, the X and Y, because the Z-axis version of it is kind of infinite. Also, the 2D colliders are a little bit more lightweight. The calculations are a bit easier and faster, so that's going to be fine. I think out of the colliders that are left, so if we go and filter for collider 2D, there are 4 available. The one that seems most appropriate is the box collider. It's definitely not a circle. The edge collider is, I'm pretty sure, the sort of thing you would use in a platformer game where you can sort of you can stand on a platform, but if you're below a platform, you can jump up through it. It's kind of a one-sided collider is what the edge collider is there for. A polygon collider lets you define a collider that's got kind of an irregular shape. So, and a circle is pretty obvious. So we're going to use the box collider here. Now, the one catch with the box collider, I will point out, is the graphic we're using does have rounded corners. And our collider is actually going to go ahead and fill in the corner over here. So I think it's going to be fine for our particular application, but keep that in mind if you're doing things. If you really did want something a bit more precise, we could use some sort of polygon collider and sort of maybe just draw a polygon that goes just a little bit diagonal at the corner here just to clip it a bit. But I'm going to be really happy with the box collider. The box collider also has the advantage of being a little bit faster, a little easier to calculate in the physics system. So by default, the box collider will properly size itself to meet the size of the graphic so that it's nicely trimmed. We can, of course, resize it. I could do something like make the box collider bigger than the box. And it might be a little hard to see, but there's a green line around here. And that actually is the collider itself. Obviously, that's not what we want here. We're going to want to go ahead and stay with the default, which on my settings is currently at 0.7 and 0.7 based on all my import settings and everything like that. It's a nice tight collider along the box. We might want to shrink a little to make the collider actually maybe the bright part, you know, the lighter brown as opposed to the darker brown. Depends on exactly what you're looking to do. For us, it's going to be fine. So the collider defines the size of this object in the physical space, but doesn't tell it how to behave with the physics engine. For that, we need a rigid body. Rigid body. Now note that it comes in two versions, the regular or 3D version and the 2D version. Obviously, we want to use the 2D version here. If we did put the 3D version on this with a 2D collider, I'm pretty sure it wouldn't work. So let's not do that. Let's use the rigid body 2D. So a lot of different settings we can tweak here. The one thing you'll note is the mass. Now keep in mind, let's do a quick little test. If I hit play right now, what's going to happen? The box is going to fall. Let's say we wanted the box to fall faster. What happens if we set the mass to something ridiculously high and hit play? The box still falls at exactly the same speed. Hopefully you guys know your basic physics. Of course, two objects of different masses still fall at exactly the same speed. In a vacuum, a feather and a pound weight will, or lead, will fall at exactly the same speed in a vacuum. So the mass here, the only thing it affects are collisions, where a very light object hitting a very heavy object, well, the heavy object's not really going to move, and the light object is basically going to bounce off. The mass is basically only for collisions, and you can look at these as absolute numbers, but they're meant to kind of be relative. Something with a mass of 10 is just 10 times heavier than something with a mass of 1. Do you want them to be pounds? Do you want them to be kilograms? It doesn't matter. It's only about the relative weights. If you do want to make something fall faster or slower, you can, if you do introduce a little bit of drag, that can affect falling speed. Also, there's this thing called gravity scale. If I set the gravity scale in this box to 0.1, it'll fall much slower. Well, it'll accelerate more slowly. It won't accelerate as much. It'll still build up speed over time, of course. The way you can cap the falling speed is by setting, for example, the linear drag, because that's a certain amount of wind resistance, at which point it'll hit a kind of a terminal speed, that sort of thing. I realize it's a bit of a more of a complicated kind of physics idea. Generally speaking, you don't have to do too much. The biggest thing you might do is toggle the gravity scale between 1 and 0. Basically, literally, either you're going to have gravity scale of 0, which means this is a physics-enabled object that is not affected by gravity, which you may want to do, or 1, which means it's affected by gravity normally. Is kinematic is a slightly different and very important setting we talked about recently. Is kinematic makes it so that this object is no longer affected by physics in any way. Let's do a quick couple of tests here to give an example. I'm going to go and take my box. I'm going to apply these changes first of all, so it gets applied to the prefab. I'm going to hit Control-D to make a duplicate of this box, and I'm going to put it down here. So we'll talk about a few things. So I'm going to take the top box again. Top box is currently affected by gravity. Well, they're both affected by gravity. If I hit play, they both fall. Let's take the bottom box and turn off the gravity scale at this point and see what happens. The bottom box will no longer be affected by gravity. It won't fall on its own, but it is still a rigid body. So when these two things collide, this thing will get affected by the impact and will go flying off in some direction. Like that. Now, it's worth noting, especially if I moved it right over to the side, this box is still not affected by gravity. So it'll sort of, fly off kind of sideways in kind of an odd way. So that's what turning the gravity scale to 0 is. If I set this bottom box to is kinematic, it will not be affected by physics forces. It will still participate in collisions, or rather, it can be collided against, but it will not be affected by the resulting force. So we can see what happens there. Now, a very similar thing can happen here if I just remove the rigid body component from the second object. It still has a collider, which means it can still be collided against. And you might say, well, what's the difference between just having a collider and having a kinematic rigid body? In terms of what the physics system expects, something with a collider by itself is a static collider. It's something that the physics system expects will never move. In fact, our platform down here, that's exactly what it should have. It should have a 2D box collider and no rigid body, because this platform is meant to be static. It's stapled to the sky or something, however you want to imagine it. It is never intended to move at all. If we hit play, boom, there we go. Whereas this box here, if we go and we give it a rigid body, but set it to be is kinematic, this is something the physics system won't affect, but it's prepared to accept the fact that it might move. For example, we could do stuff like this. Now, you can sort of do this with a 2D collider as well. Now, the end result of these two is pretty similar. Note that these two don't interact with one another in any way whatsoever. In fact, if you have a script that has a function on it called onCollisionEnter2D, that will get fired every time this box actually slams into another box. Whoops, it'll actually trigger that collision. But these two will never trigger collision against one another. However, if their box collider was changed to is trigger, then they would interact each other and they would cause a trigger event to be fired. If you want to learn more about that, go and watch my 2D space shooter tutorial where we use triggers extensively. We're not going to use triggers in this, I think, but we are definitely going to use collisions. Anyway, enough of that little bit of a talk. I'm going to get rid of this second box. Obviously, our box seems to be the sort of thing that should be affected by gravity most of the time. And obviously the platform at the bottom should be a static collider. So we've got the start of our game over here. In the next episode, what we're going to do is we're going to figure out a couple of different ways we might want the box to move, and also we're going to start interacting with it with our mouse. Actually, I'll go ahead and do a little teaser. We're going to go ahead, I'm going to take the box, and imagine maybe what we want is the box to float in from the left side of the screen. How might we get the box to float in from the left side of the screen? Very easy. First of all, let's take this box. Let's turn on gravity scale of 0. Okay? So now it won't fall anymore. Then let's give it a script. Let's call it something like initial velocity. All this script is going to do is it's going to give our box an initial velocity. So I added a new component on here, which was a script in C# called initial velocity. Check your spelling. As always, capitalization and spelling matters. Also note that the name of your class has to match the name of your actual file. So all this is going to do is it's going to have a public vector3, which is going to be called init velocity. And in the start, we're just going to grab our rigid body component. So we have a rigid body component we can reference. If we don't actually have a rigid body on our object, for example, if we, so over here, if we don't actually have a rigid body, that will not, that will be null and you'll get an error. But we do, and rigid body has something called velocity, and we can just set the velocity to this init vel. So, because while gravity is turned off on this object, it is not kinematic, so it's affected by the forces of physics. And if we give it a velocity, for example, maybe a negative x velocity of, say, 3, and we hit play, this should give me an error. There's no rigid body attached to our box. Right. We don't actually have a rigid body. What we have is a rigid body 2D. I don't know if there's a... Oh, there is one for that. There's a rigid body 2D. There's not a rigid body, but there is that. Let's hit play again, and it should work. There we go. So now we've got our box with our velocity. If I did turn on the is kinematic and hit play, our box, unless I'm wrong, it still moves. It still uses velocity. Interesting. Interesting. I don't think I was actually... Oh, no, I did. I was aware of that. Didn't we do this in our space thing? No, I did it in another space thing. My bad for the confusion. Anyway, we've got our object that can move here. And I guess the question is, let's say I take my platform and I just duplicate it and move it over here. In the case where the box is not kinematic, it's a rigid body, not affected by gravity, but it's not kinematic, so it bumps against the box and then stops. In fact, if I take it and move us up a little bit higher, we'll again see the thing where it's sort of boom, like that. So it can still be affected by collision. So if I turn on is kinematic, it'll go straight through the box and be unaffected, because kinematic objects are not affected by anything in the physics system, neither collisions or gravity or forces of any kind whatsoever, but they do affect other objects if things bump into them. All right, we're going to call it a wrap here. Next episode, we're going to look on how we can click on this box and have it do things. See you next time, folks. Bye-bye.